Here we go for the Edexcel Higher. It's from the June 2024 series and it's paper 3, so calculators at the ready. So highest common factor, it's one of those where if you've practiced enough, it's pretty obvious. One thing to speed things up, don't be afraid of three-way splits. So instead of going 9 sevens, 7 times 3 times 3, here 7 times 3 times 5, 7 threes make 21. And off we go. So 7's in common, 3's in common, get them multiplied, and you've got your HCF. Practice makes perfect, speed things up, no silly mistakes. Standard form. So first one, positive power, so a large number. Move the 5 and the 3 to the left. Becoming 53 means we've times it by 10 once, twice, thrice, and 4 times, so that does the job. Negative power here, so what we've got to do is move the 7 and the 4 to the right hand side. Now if I put it there, that'll be moving once, so we move it twice, thrice, 4 times, and you can do a count as you go along. 1, 2, 3, that's only 4. We need another one. Don't be afraid of using a pencil. Got some working out space, feel free to do loops. It's entirely up to you. And for part B, I know it's on a calculator paper, but I would certainly recommend for revision purposes, you try, when these questions pop up, try them without a calculator and use your calculator to check, because this is definitely one where the powers are close. So don't be tempted just to stick it all in your calculator and off you go from there. So I would go for this the non-calculator way. So what I'm going to do is I'm going to take the first number, I'm going to increase the power by 1 and decrease the number divided by 10. Now what that means is we've got them of the same order. So that's going to be part of our answer. Now the bit you can do on your calculator, 2.45 plus 0.97, or just add 1, 3.45, and take away 3 pence. But definitely one of them to practice without a calc. Don't, if you keep relying on your calculator, what happens one day when it pops up on the non-calc? Because at some point it will. On we go. So Rana is trying to draw the side elevation. Now what basically she's done is she's drawn it as if she's looking from that perspective, because the 7 is indeed correct. But she's looking at it, she's drawn that 4 squares high. So it's as if she's looking from that angle at a perpendicular, like so. So the real height, the true height, should be less than 4. You don't have to go into any Pythagoras or any rubbish like that. It's only 1 mark. Just any explanation that says the true height of this prism should actually be less than 4. That will pick you up the mark. I've cheated for part B because me and technology just don't mix. But there we go. So on the centimetre grid, draw below the plan. So as you look down on it, it will be 7 in that direction. It would be 6 in that direction, and the ridge along the top would definitely be along the midpoint of that. Always use a ruler. Number 4, very, very bog standard in my opinion. You've got your capital, in this case it's amount of workers. Get your first mark. If you want to increase by 6%, so 25,000, just stick it in my calculator, times 1.06, but it's power of 3. And when you hit equals 29775.4, but it's number of workers, so although it doesn't tell you how to round it off, it's nearest whole number because it's people. So 29,775, excuse the handwriting. So here we go for question 5. Very much overly wordy, very much too complicated. But as soon as I see things like grams per centimetres cubed, I start writing down density, mass, volume. Now, if you read through the question, feel free. I'm not a fan. As you can see, I prefer to separate and work on one part at a time. So up here, he puts, so we've got the mass, we've got the density, volume equals mass divided by density, so 600 divided by 0.6 on your calc or mentally comes out as a nice 1000 grams centimeters cubed for the tin, but the key here is they're identical. So we now move on to the second tin. We get 600 grams of salt, so again that's mass. The salt does not fill completely, not filled with salt. So what that means is 1000 take away 700. That is the volume of the salt. So work out the density of the salt. Density is mass divided by volume, and the mass is 600. And that's why I said it could easily be a non-calc question. Nice answer of 2. On we go to number 6. Cheated slightly by putting in the bland information. You all know where those have come from. Let's get straight on. Work out the probability of landing both on heads. Well, there's heads. There's heads. So it's these two things which need multiplying together. So on my calc, 0.6 times 0.55. Yes, I'm doing it in real time. I get 0.33 as my answer for a nice straightforward probability tree. Number 7, paddling pool. So these, again, they're trying to be overly wordy. Top two things, who cares? They've given it on the diagram. It's then filled. So as soon as you start filling, it's a volume question. So before I read on, volume of a cylinder is pi times the radius squared. All right, obviously didn't need that. Times by the height, and so on. So 100 times 30, 300,000 pi. That's in centimetres cubed, don't forget. Now, it is then filled with water at a rate. So we need to take this and divide it by 250, which gives us 1200 pi, which gives you it per second. So to go from seconds into minutes, we need to again on a calcs divide by 60. I'm getting the answer of 62.8 minutes. Nearest minute, I'll call it 63. Mark scheme allows 62 to 63. 62 is acceptable. According to the mark scheme, I think 63 should be the only right answer there. Number 8, good old vectors. So 2a, so I would always write it down. 2a means double the movement. Added to b means just add it on. And with adding, subtracting vectors, you add and subtract common elements. So the top elements, 6 take away 1 is 5. 4 plus 4 is 8. And you can draw it anywhere you want. I always start in a safe, if it's 5, 8, it's going right and up. So I would like to start in a safe place. 5 to the right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Reaching for a ruler. Come on, technology. And that will do the job. Ish. On we go. So for number 9, And another volume question, couple in reasonably quick succession. So it says the volume of the cube. Don't read on, work it out straight away. The volume of the cube is 6 times 6 times 6, 216, is equal to the volume of the pyramid. Now, a volume of a pyramid, look it up on your formula page. Volume of a pyramid is a third times the area of the base times the perpendicular height. You've got your equation set up. Now solve it by doing opposite. So on my calculator, I'll start with the 216. I'll times it by 3, 648, and I'll divide it by 64. I'm getting 10.125 centimetres. On we go. So number 10. Another waffly one and a ratio one, but let's take it one thing at a time. So top line, there's only red and yellow counters in bag A. Bag A, red to yellow, are in the ratio 3 to 5. Only green and blue in bag B. The number of counters in bag B is half the number of counters in bag A. So let's just make sure we're okay with that. Number of counters in bag B is half number of counters in bag A. Given that there are X red counters, so there we go. So to go from red to yellow, how do we get from the number 3 to the number 5? It's multiply by 1 and 2/3, or in other words, 5/3. Which means the total number in bag A, if we add 1x to 5/3 x, we get 8 over 3x in bag A. Now it says there are half as many, so in bag B, half as many would mean we've got 4/3, just half the numerator, like so. Use algebra to show that the total number of counters in bag A and B is 4x. So total means add 8/3 plus 4/3 is 12/3. And 12/3 is 4x. Wish I'd given myself a little bit more room, but there we go. Not a nice question. One of them that's very much more complicated than it actually needs to be. So question 11 brings us to good old box and whiskers. So nice and straightforward this one, in my opinion. So as soon as you see lowest speed, get a little notch on there at 25. Lower quartile, get a notch on 35. Median, same goes. The next two, got to do a little bit of working out. So mental arithmetic and calcs at the ready. Interquartile range is 12, so that needs to be added on to the lower quartile to give the upper, and need to do lowest speed plus the range to give you the highest. I always like to put the notches on first, and then you can start the process of tidying the whole thing up, forming the box and your whiskers. Now when it comes to the next part, when you're comparing things, always pay attention to how many marks it's worth. It's worth 2, so there's probably going to be 2 categories of answers. So when you're asked to compare distributions, always make a comment about the average, the mean, the middle, in this case the median. All right, so you can obviously see that the one on Sunday is 2 higher than the one on Friday. Any words to that effect will get you the mark. Once you've mentioned the average, then mention the spread. Don't have two sentences both commenting on spread. You want to get average and dispersion. All right, so either sentence to say something along the lines of the IQR is larger on Sunday or the range is larger on Sunday. It doesn't really matter which one you go for. On we go to number 12. So, nice enlargements. Now, I always prefer to do these by counting, and I use the Ray method as a way of double checking, which will show at the end. So, first of all, notice the center, get it marked. Then, mentally note your scale factor, and I do it by counting. So I'm going to count right 1 up 2. So a negative means right 1 becomes left 2, up 2 becomes down 4. And then goes my new coordinate for where the right angle of this triangle would be. Carry on counting. This vertex here is 3 to the right, 2 up. So multiply those movements by -2. And you end up with 6 left, 4 down. And same goes for this one. That's 1 right, 3 up. So 2 left, 6 down. Tidy up your answer, but always worth, doesn't take too long to grab a ruler. Make sure that corresponding vertices all line up going through the center. So when you've got an enlargement, I do prefer that method as a way of double checking, not as a way of actually doing the question. Number 13. Now, before we actually discuss the question, let's just remind ourselves that if you pick two students from a class, let's say you've got student A and student B, that could flip around. You could have student B first and then student A comes along second. That would be the same team. Okay, let's just make that distinction. So I'm afraid this is not as straightforward as just doing 30, because your first student can be picked in 30 ways. Your second student can be picked in 29 ways. But because the students flipping around, as already explained, gives you the same team, you do need to take the answer of 870 and divide it by 2 for 435. Number 14. Heck of a long-winded question, this one. It's all loads of stuff going on. The idea is reverse the flow. I do this one like a number machine. At the start, she invests some money. We don't know what it is. But it's paid 3 points, so it gets multiplied by 1.035. And she then takes £750 out. Next year, interest again, same rate, and she takes £1,000 out. And that's all going in that flow like that. And she ends up with £2,937, 14 pence. So how much did she have right at the start? Calculators reverse. So I'm going to type into mine. Yes, it's real time. 2937.14. We add 1,000. She's got 3,900 odd. We divide it by 1.035. So at this stage, we're at 3,804. But then we're going to add £750, 4,554, and then we're going to divide by 1.035, and I'm getting a nice answer of £4,400. Obviously, you could do it in algebra approach, but why bother? Number machine's much simpler. Number 15, we have some nice algebra. So 15a, so as you can see, it's only worth 1 mark. So the brackets are repeated, so they cancel out. A minus 3 on top over 5 on the bottom. Number 5, so when we factorise this, we know our answer is going to be 2 brackets. We also know it's going to be 3k and k. And I know some people are really good at just guessing, trial and error. Not a fan myself. I always go AC because what happens if the numbers are really big? What happens if there's 84 on the end instead of just a 4? So you could just sit there because -4, there's only going to be -4 plus 1. I'm not a fan. Just because this one's easy to do by guessing doesn't mean the one you'll get in the exam will be easy to do by guessing. So stick to the AC method. It will be your best friend. A times C, 3 times -4 is -12. I want pairs of numbers which add together to make +11, but multiply together to make -12. So we've got +12 and -1. Started to write X then. I obviously meant K. I always tell my students to split the page in 2, factorise the left, factorise the right. What do these have in common? A 3 and a K. We expected that. 3k times K and 3k times 4. So we're hoping we get the same thing over here. What do these have in common? -1. So we take a -1 out, we factorise that out, we get a K and a +4. And the moment they repeat, you know you've smashed it. And the leftovers give us the other bracket. And for C, lots going on. 3 marks. I'm a big fan of just one thing at a time. So dividing by a fraction, no, is the same as multiplying by the reciprocal. And X plus 2 on the bottom. Let's take this first fraction on the top. Not an easy spot, but it's 2 minus X, 2 plus X. Difference of 2 squares. On the bottom, what have these got in common? Just an X. And whenever you're faced with these questions, you're hoping at this stage that lots of things cancel out. So a 2 plus X on the top, a 2 plus X on the bottom, an X plus 3 on the bottom, and an X plus 3 on the top. So all that's gone. The only things we're left with is 2 minus X over X. They always work out quite nicely. If lots of stuff doesn't cancel, double check you've factorised things correctly. Functions, not the friendliest looking, but I always think these are pretty good for a little gold mine of marks. And don't forget calculators at the ready. Be careful with calculators if you're subbing in a negative. So find the f of -3, that means take the function f, replace the letter x, and there we go. So again, don't overly rely on your calculator. -3 plus 1, -2, it's all divided by -2, -6. Yeah, I'm doing it without a calculator because these are also very popular on non-calc papers. Find the f of g of 1. So always think of it as you work inside out. F of g of 1 is really this. And if you've got brackets inside brackets in BIDMAS, you do the inside first. So 1 needs to go into the g of x. Okay, 1 needs to go in. So we get 5, take away 3 ones, we get 2. F of 2 means stick 2 into the function f. 12 over 2 plus 1. 12 divided by 3 gives us 4. Now for C, you got lots of ways of doing this. I'm going to go with the rearranging because again it's good for revision. Let's do the inverse function. Not the quickest way, but good for revising. So let's rearrange this. So I want to make x the subject. So I'm going to add 3x to both sides, take away y, and then divide both sides by 3. So that's my inverse function. My inverse function, if I want to call it g to the minus 1, is 5 minus x all over 3. And we need to substitute the number 4 in. 5 take away 4 is 1. 1 divided by 3, leave it as a third. Another one that could be done via number machines and other methods, but I prefer that one better for your revision. So a load of waffle for number 17, basically disguised iteration. So the idea is make sure you multiply by 0.55 the correct number of times. So don't be afraid of just laying it out a little bit basic like this. So the first bounce you're told 8 meters, second bounce it's times by 0.55 and again and again. Doesn't tell us how to round this off. So, but that's the right amount of times. Don't have to worry about this n plus 1 or malarkey. Stick it in your calculator as in power of 3. And I don't round it off. Leave it as 1.331 meters. Number 18, you can tell straight away it's double sine rule, cosine rule, or whatever, because we've got non-right angled triangles. When I see a question like this, I do like to write on the diagram, that's worth 54, that's where we'll start. I've filled in that extra angle of 75. It might help, it might not. So, checking your formula sheet will remind you that the area of a non-right angled triangle is given by a half AB sine C. In this case, replacing A with, because ignore their labels, at the end of the day, 17 is one of the sides, x is the other side, and those two sides must be split by the angle between them, in this case 35. So, as you can tell, you can stick that in your calculator doing the inverse operation. So start with 54 times by 2, divide by 17, divide by sine 35, and always work to a higher level of accuracy than you're ultimately going to be asked for, so work in more than 3 significant figures. As you can see, stuck a line through that one now because all the focus is on the second triangle, the ACD. Now, in order to work out the area of ACD, you're going to be needing another side. 75 is going to play a part. If you've got AC, you're going to need either AD or CD. It's entirely your choice. Whoops. But I obviously have gone for using the sine rule. I've gone for the side I've just worked out, AC 11.076, divided by the sine of angle D, in this case 57, and that will equal the side AD, top one, all over sine of 48. And as we know, stick that in your calculator, left-hand side, and multiply by sin 48, and you'll get the length of A to D. Again, more accuracy than the final answer required, so I've gone for 4 significant figures here. So that means you've now got AD, you've also got AC, you've got these two sides. You can now use the half AB sine C again. So the area of triangle ACD is going to be a half multiplied by the side you've just found, by the side you found earlier, by the sine of the angle between them, 75. And all in your calculator, it'll obviously spit out a long decimal, but 3 significant figures required, so 3 significant figures given. On to number 19 for some bounds. Another wordy one, trying to overcomplicate, but as soon as I see the phrase lower bound, and you've got a quotient, in other words a fraction, the idea being I want the numerator of this quotient to be as small as possible. I want the denominator of this quotient to be as large as possible, and that will give me my smallest possible answer. So on the top, the 5.88, which was rounded to 3 sig figs, I nudge it down to 5.875, go down by half the rounding amount. Nothing to do with the powers of 10. And on the lower bound, on the lower part of the fraction, I want that to be as high as possible. So take the 3.6 up to 3.65. Now's where you can reach for a calculator. Powers, that's the easy bit. 8 take away 5 is 3. The rest, stick it in your calculator, but as always, go further than you're needed. I've gone for 5 decimal places there because I'm going to need to times it by 3. In other words, move the decimal point 3 times. Again, could do it on your calculator. Could do a whole lot on your calculator, to be fair. But again, like I've mentioned earlier in this video, I like to do as much without a calculator because who knows, on a certain day, could easily have cropped up on paper 1. So I get 1609.58, etc., etc. It wanted nearest integer, so give it nearest integer, 1610. On to number 20. So with an arithmetic sequence, the main thing to realise is if you do third term minus the second term, you would find the common difference. And if you did second term subtract first term, you get common difference. And as you can see, you can set these equal to each other because the common difference should be the same. Removing the brackets, be careful with negatives, adding 1 to both sides, answer of 7/2 or 3.5. Same principle here, except with the geometric sequence, you want to find the ratio, the common ratio, the multiplier in other words. So third term over second will equal second term over first. Now before you start timesing, do make sure to remind yourself these should all have brackets. Cross multiply, so multiply both sides by y minus 4, both sides by y plus 2. You don't need to write this line out, but because it's worth 5 marks, I decided to. Expanding the brackets, again, you could show more working out than I'm doing. I haven't shown the bit of simplifying, I've just gone straight to the answer. So another line of working out could be your flavour. And once you get to this stage, equate to 0, so subtract y squared from both sides, subtract 4y and subtract 4. Now we did the AC method on an earlier question, so could use the quadratic formula because it just wants the values. You could have gone for factorising by sight. It's got to be 2y and y, and by sight the only way I can get a negative 15 is negative 2 times negative 8 and 1 times y, giving me the two answers. However you get there, it's entirely up to you, of negative a half and 8. Oops, on we go. So this lovely final question, hopefully you all love this one as much as me. But let's just talk through a few things. Firstly, this inscribing hexagon. So that distance I'm mapping out there is the radius. And these inside will all be equilateral triangles. So just to point out, the length PQ, QR and so on, they will all be equal to the radius. So at least start with that principle. If you don't get your teeth into the entire question, you can at least state that the inscribing hexagon has a perimeter of 6r. It's the external, the circumscribing hexagon that's the real pain, because obviously you know that the perimeter or the circumference of the circle is 2 pi r. So again, blag an easy mark for stating that. But the real work is about the outside. So I've put a couple of crosses on there just to illustrate a reminder that that would be equilateral triangles will give us 60 degrees. Let's go to the left-hand side to chop that in half. So, yeah, let's go in the middle. So that gives us 30 degrees there. Now, putting that in allows us to apply a little bit of SOHCAHTOA. The radius of the circle is from the centre to there, which is where we get the tangent going on. So by using the TOA part of SOHCAHTOA, we can say that the opposite x is equal to the adjacent r multiplied by tan 30. And obviously you can stick in your calculator if you want, but the fact that the answer's got surds in it, hopefully you get a calculator that works in the surds, but root 3 over 3 is the tan of 30. Now that x there, just to explain, is half that, so that means there's 2x there, there's 2x there, there's 2x all the way around. So in other words, the perimeter of the outside hexagon is 12 of these x's. We now actually know enough that we can move towards the answer. So, I've colour coordinated. The outside hexagon is 12 lots of what we've just found. Let's tidy that up. 4r root 3. As already mentioned, the circumference of the circle, we'll do that in orange, is 2 pi r. Nothing to tidy up there. The inscribing hexagon, moving into purple, there are 6 of them all the way around. And as you might be able to spot, you're nearly at the answer. It wants pi in the middle, and the only way you can have just pi in the middle is to divide every term by 2 and r. So switching to black, divide by 2r, and you get 3 on the left-hand side and 2 root 3 on the right-hand side. What a lovely, easy question to finish off with. But enjoyed that one. Hope you enjoyed it as much as me. Hope that walkthrough's helped you on that paper, and I'll see you on the next one.